of the products and the reactants in this one. Which has more energy, the reactants or the products? If I were to add up all the energy and all the chemical bonds of the reactants, add up all the energy and all the chemical bonds of the products, for an exergonic reaction, which one has more energy?
Products.
Does it release energy or do you add energy?
Release.
Releases. So that means coming out of this arrow here, there has to be some energy. So who has to have more energy? Reactants. Reactants have to have more energy than products. So we release energy. Right? That's what that says. So that means that endergonic reactions, we're putting energy in, so we're adding energy to the reactants so the products have more energy. That kind of makes sense? We call the energy exchange here, if it's energy that's available to do work or came from doing work, we call that free energy. So you should have had this in chemistry class. We call that free energy. It was described, I guess, initially by somebody named Gibbs. So it's called Gibbs free energy, and we abbreviate it with a G. And so for this here, there is a change in free energy. There is a change in free energy for each one of these reactions, right? And if we do energy of the products minus energy of the reactants, this one's going to be negative, right? And this one's going to be positive. Does that kind of make sense? Because here we had to add energy, so it's a positive delta G. Here we released energy, so it's a negative delta. Is that good? You okay with those words? Because you'll hear me talk about energy change, free energy, G, delta G, that kind of thing.